Hi! Today we're going to learn about polar differentiation, about the polar differentiation formula in calculus, or basically how to calculate the derivative of polar equations. Let's say we have to identify the polar differentiation formula. So, how do we do that? Well, let's go back to parametric equations. In parametric equations, we had like an equation like this: y is equal to something in terms of 3t. So let's say 3t plus 2, and x was equal to 5t minus 3. And so what we would do is we would do dy dx, or dy dt over dx dt is equal to dy dx. So we can see that we can use these differentials sort of as fractions. So let's keep that in mind as we do our problem. So even though this is a polar equation, or even though this would be a polar equation and would be in terms of r and theta, we still want to find dy dx. Now let's list some common rules between rectangular planes and polar planes. So we know that x is equal to r cosine theta, y is equal to r sine theta, x squared plus y squared equals r squared, and tangent of theta is equal to x or y over x. So those are some of the common rules for rectangular and polar planes and converting between them. So now we have to identify what the polar differentiation formula is. So if we remember from parametric equations, dy dt over dx dt is the same thing as dy dx. So following the same logic, dy dx should be equal to dy d theta over dx d theta. And it is the same, or dx d theta. And this is equal to dy dx, because if we use them as fractions, they'll cancel out. So, or the d thetas will cancel out and we'll be left with dy dx. So let's do this. Dy d theta is equal to the derivative of this. So this is implicit differentiation because we have an r here that's not supposed to be there, and we don't have this, we're not differentiating in terms of r. So this is equal to dy d theta is equal to dr d theta, or r prime, times sine of theta plus cosine, or plus r times cosine of theta. So all we did here was apply the product rule. The derivative of the first times the second plus the first times the derivative of the second. So r prime times sine of theta plus r times cosine of theta. Now let's do dx d theta. Dx d theta is the same thing. With the product rule, we have the derivative of r, dr d theta, times 2, which is cosine of theta. And 2 is just the second term. It's not actually the number 2, so it's the first times the second. So r prime, or dr d theta, which is the first, times this, which is the derivative of the first, times the second, which is cosine of theta, minus, or we'll have plus, sorry, we'll get to the minus later, plus the first r times the derivative of cosine of theta, which is negative sine of theta, so we can change this term to a negative sine of theta. So now what do? We have both of these, dy d theta and dx d theta. So all we have to do to calculate dy dx is divide dy d theta by dx d theta. So this is equal to dr d theta times sine of theta plus r cosine of theta over dr d theta times cosine of theta minus r sine of theta. Today we learned about polar differentiation formula in calculus. Thank you for watching this video.